Okay, now our next speaker studied computer science at the University of Würzburg. He then completed his PhD at TU Darmstadt in March 2009. And then he worked in motion development, afterwards at Bosch Connected Industry. For example, he was the product owner for the IoT gateway. And since July 2024, he is a business owner for Motion, responsible for strategic initiatives in motion solutions and robotics. So please welcome from Bosch Rexroth, Dr. Holger Schnabel. Welcome.
So thank you very much for the introduction. Good afternoon to everybody. It's a pleasure for me to talk the next few minutes about industrial robotics in transformation. What is it about? Industrial automation is changing in an incredibly fast way, and of course also robotics is at the heart of it. So now let us see what I prepared. First, I will say a few sentences about who we are. Afterwards, we will discuss about the challenges in today's industrial robotics, what hurdles and obstacles are the customers face today. Then we are talking about the customer needs for open, secure robotic systems using open ecosystems, and closing I will with a summary out of it. Okay, first, to get you an impression who we are located in the Bosch business sector. There we have 4 sectors. One is the mobility solutions. They are developing all future technologies for your cars to make them, for example, safe. We have the energy and building technology, who connects everything in the buildings. The consumer goods, who develop products who improve your daily life. And industrial technologies, where Bosch Rexroth is located. It's divided in 2 parts. One part is hydraulics, the other part is factory automation. We are in factory automation and providing controls, drives, and motors. And of course, on top of it, also the software for robotic motion control. Okay, now starting my presentation, I first want to ask you a question. What has a Swiss pocket knife in common with industrial robotics in the future? So I think, as I can see in a first surface, not so much, but let us have a look a little bit deeper, then I think it can be more insightful. If we have a look at such a Swiss pocket knife, what can we see? It's not just a tool, it's a complete toolbox. You have knives, you have scissors, you have bottle openers, you have saws, and independence of the job you wanted to do, you choose the right tool. If you want to do another job, you choose another tool. So you are completely free of modularity, it's highly efficient, and it's completely versatile. And it's also in a very compact and elegant design. Now, what has it in common with industrial robotics? To discuss it a little bit more, let's first have a look of today's system. Today's system in robotics are mostly closed and based on proprietary systems. Closed system means if you want to implement something in a robot control deep inside the motion, for example, then you normally are completely limited in interfaces, or for example, even in cycle times for some deterministic stuff you wanted to do. A little bit other way around will be future robotic system. What do you want to have there? You want to have modularity. That means you want to have software modules, apps, where you can integrate the software you wanted to have. You want to be versatile. Yeah, that means you wanted to integrate the features you need for the job without doing everything new. And of course, you wanted to support all open standards and also all common ecosystems in the robotic world. Okay, now let's have first a look about the task a robot control has to do. If we have to look on the left side, then of course a robot control has to connect to upper level systems, for example line controls. There you need common field buses, for example Profinet, Ethernet IP. TSN 5G, that could all be possibilities. Second thing, if we have a look in the upper level, then we see we have to communicate with the factory. That means IoT, OPC UA, you have to provide data from your robot to upper level software systems to make some additional evaluation or remote condition monitoring. To do this, of course, you have to be secure. Without security, you cannot connect to the factory level. And device management, you have to do software updates to your device, which will also be done out of the factory. Of course, the main task you can see on the right side, it's a robot control. Of course, you need the motion to control your robot and your kinematic. And last but not least, you have the user on the lower side. He, of course, wants an easy-to-use HMI. He wants to program the robot. He wants to do the commissioning and everything in a very, very easy way. So now, if you want to start with a robot control role, you don't want to start at scratch. You want it first to have a toolbox which you can use out of the box. If you have a look here we have a topology picture of such kind of a toolbox. That means if you have a standard application, you want to have everything ready-made. That means on the left side, you want to have a robot HMI with a flexible commanding. That can be a script-based programming. That can be a graphical programming, also called low-code in the robotics segment, or also PLC programming. Then you have the robot control itself. There, of course, you have the motion. You have the EtherCAD to communicate with the drives. You have a PLC to connect to the periphery, and also OPC UA to connect to the factory level. And then we also have the drives, motors, and the kinematics. Of course, it's only a topology picture. Drives, motors can be much closer or also integrated in the kinematics. Yeah, that's completely clear. Now you have an out-of-the-box system, but now you want to differentiate from your competitors. You want to do something by your own, and you want to be flexible. That means you want to integrate your own customer IP in the system and extend the out-of-the-box solution. Okay, for this we will start on the right side for the robot kinematics. You have a new kind of kinematics. What do you want to do? You want to support it, of course, with a motion. If it's not supported by the robot supplier, normally you have to ask them, but you want to have open interfaces to do it by your own. That means, of course, you want to have the flexibility and openness to do the implementation of the kinematics so that it fits best to your mechanics you have. Second thing is, if you have a mechanic and you want to optimize it, that means perhaps you don't want to have the most expensive kinematics because of some cost pressure, for example, out of Asia, then you want to do some software optimizations. You want to integrate filters inside the software, for example, vibration damping, to reach a best price performance ratio, because you can optimize your hardware via your software modules. You can integrate by your own. Third thing we have a look at on it, you want to integrate perhaps your own programming language. You want it to make very easy for your customer to insert his own programming language, so he can use all the APIs which are available, the motion APIs, and he can directly connect to the motion control and can implement his complete own programming language. It can be script-based, it can be a real-time script-based language, or it can be even a graphical programming. That helps you to reach the best usability and also extendability of your system. Okay, and now what you also want to do, if we are talking about robotics, there are many ecosystems. I think from research side, we know ROS2 very well. And of course, what do you want to do is you want also to use such ecosystems which are already available. And therefore, of course, you want to have an interface to connect all tools known, for example, from ROS2 directly to your control and use all the simulations, the commissioning stuff, which is already available in such well-known ecosystem inside your control. That means using well-known open source tools and connect it also to the robot control to come inside other ecosystems. And I think we talked a lot about what you also want to do. Of course, you wanted to integrate something with AI. What are examples for it? You want to do perhaps a path planning with AI. You wanted to detect some obstacles, and you wanted then to calculate a new motion path, or you only want to detect some work pieces out of it. Yeah, therefore, also the robot control must have the capability also to integrate AI solutions, mostly based, of course, on Python. And that enables you that you can integrate AI algorithms on your robot control for path planning or even for robot perception. Now, what we have discussed, it is a very open system. The developers can do everything they want, so I think developers would be very happy with the system. But now we want to productize it. And now you see some things developers normally don't like. It's about security and it's about fulfilling norms. Of course, therefore, you also wish that you have a robot control which already brings everything with it, which you need to fulfill all the security stuff. For example, let us talk a little bit about the Cyber Resilience Act, which will get active end of 2027. And of course, if you want to bring in any robot control in the market afterwards, you have to fulfill it. What does it mean? Only to have a short look about what you have to fulfill. That means security is always a key requirement, and that is over the whole life cycle of your product. By shipping, of course, you ship it with a minimal footprint. You ship it with only secure protocols like HTTPS or OPC UA, but also in the entire product life cycle, you have to deliver software patches. If there's any security incident, you must be able to shift software updates to your customer. That can be done, of course, with a central software management, and also important that you are able to update single software modules and not to flash only firmware systems. And of course, for the security stuff, authentication and authorization is also very, very important to fulfill such kind of requirements. Now we are at 2025, and perhaps you ask the question, how can I make sure that a control today will fulfill the Cyber Resilience Act? There are also possibilities already up of today. There are certificates. It's the IEC norm 62443, and the requirements of this norm are really nearly completely similar with the Cyber Resilience Act. That means if you have today a robot control which fulfills this norm, then you can be sure that it will be also fulfilling all the Cyber Resilience Act requirements in 2027. Okay, that was a short overview, and now we make the summary how a robotic solution should look like. You see it here. A robotic control should be as versatile, flexible, and modular as is with pocket knife we have seen at the beginning. What are key or main elements out of it? You wanted to integrate, of course, user kinematics to support all kind of mechanics. You wanted to optimize your mechanical design via software, for example, via the vibration damping. You wanted to integrate your own programming languages to bring your own look and feel to the customer. You must be ready for the support of third-party integration for the ecosystem, like the already mentioned Cross2. You have, of course, you need AI-ready control, and last but not least, everything has to be secure and certified that you will be able also to deliver your robot and the robot control to the customers. Okay, thank you for your attention. Now I'm open for questions.
Thank you, Holger. Great insights. What to me is kind of really remarkable, I hear a lot now, easy to use. Mm-hmm. Is it so complicated what we are developing to use it? Is it so much technology that it's kind of hindering those who shall play with it the easy way, cannot play the sounds anymore. Sorry, that alarm is always my session is over alarm if it beeps. So it's not that somebody is trying to reach me. And coming back to the question.
So I think complicated. So I think we Germans love technology, and so we think all our customers love technology, and so we didn't care so much about if it's complicated. So because we can show the technology, and there we accept it's complicated. But our customer wants to have it as easy as possible. They want to commission it in 1 day, 2 days. They wanted to have a ready toolbox. But if they want to extend it with everything what is available in the market, and that is one of the focus we provide here.
Okay, great. Any questions from the audience? Yeah, there is one in the center, and there is a second one, and there also? No. Okay. Both sides, center.
Yeah, so to me this looked like the robotics is seen as what we often refer to as self-hosted. So all the parts planning is done by this controller, and there's, I think, Bosch or Rexroth servo drives. Do you also see remote-hosted options? So as I work for a robot company, I'm afraid we won't sell any robot controller anymore. But do you think that would also connect? So using an interface like SLCI, that you could connect a normal robot controller to this concept?
Yeah, of course, that's also one of the things. I think even on my third slide, we already mentioned the SRCI interface, which has also, of course, relevance in that kind of sector. Yeah, that's completely right.
Yeah, and for the there we have the picture with the kinematics. So I even see a six-axis robot on the lower right side. So that kind of kinematics you support today?
Yes, this kind, everything what is shown here, everything is supported and already available. Yeah.
And often used with robotics is also safety functions. Is that also included here?
I take it out the safety because I need some more topics for next year. No, only joking. So I take it out here on the fair. We will also show a software solution, which is a safety software solution, which is also running on the control. And there also the safety parts will be included on the robot control.
Okay, now we need to start to worry as robot vendors. Thank you.
When you talk about the fair, are you talking about SPS?
The SPS fair, end of the month.
3 weeks to go, 25th of November.
Yeah.
Nuremberg. Okay, any more questions here in the center?
Yeah, thanks first of all from PLC-centric view. I fully agree with your presentation, and yeah, happy to say that the safety part is a bit more solved on our end already. No, but a little bit provocative question maybe, because in the beginning you said the vendor lock-in. Yeah, so I was really curious what you would present in terms of how you prevent this. To be frank, of course, there's also a certain vendor lock-in looking at this page, right? So what would be your answer then? So now you presented maybe the Victorinox or the Böker knife, but still I do see a vendor lock-in.
Of course, a little lock-in you will have every time, but what is a little bit different in developing everything about the control, we support also open ecosystems. Even if you want to implement your own app, you take all the tools you know from the internet. Yeah, you need nothing from Bosch Rexroth to implement your app. You can use tools you are well known. Yeah, well, one additional thing perhaps is about we also provide the software running on the robot control, the Control XOS, as a standalone software, and if somebody wants, he can also integrate the software on the hardware. And so, of course, we are doing much less logins inside, and the system is open that you can integrate you on all the levels, and the customer can program in the same. Have the same interfaces we use in our development insights, and that is meant with much more open and nearly no login effect.
So rather software-oriented, I would say probably, right? Thanks.
Okay.
All right, perfect. In regards of time, I would say we continue to network and ask Holger outside during our next break. And we will continue in here in 20 minutes, 20 past 3 o'clock, back in the plenum, please. Enjoy your coffee break and the talks. And thanks, Holger, one more time.